Hello, this is Scholar Strife doing some geometry today. Today we're going to look at the converse of the Pythagorean theorem. So Pythagorean theorem, once again, is if you have a right triangle, then a squared plus b squared equals c squared. But we can also go backwards. If c squared equals a squared plus b squared, then it's a right triangle. So once again, let's draw this picture here. So if this little a squared plus this b squared and this little equals c squared, then it is a right angle. Alright. And then we have two theorems. If c squared is less than a squared plus b squared, then it is a acute triangle. That means all the angles are shorter than 90, smaller than 90. And if c squared is greater than a squared plus b squared, then it's an obtuse triangle. That means it has an angle longer than 90. Not all the angles, but just one. So let's do that. So once again, methods for classifying triangles. If it's equal, it's a right triangle. If it's less than, it's acute. If it's greater than, it's obtuse. So let's try and figure this out. Are the triangles shown right triangles? Okay. So we're gonna do shortest two sides. So 6 squared plus 9 squared. Does that equal 3 times the square root of 13 squared? Okay. So 6 squared is 36. 9 squared is 81. And that'll equal 117. Then how do we do this one? So there's two different methods. So let's look up here to the top left here. 3 square roots of 13, and we want to square it. So there's two methods. One way is I'm going to apply this square to both numbers here, the 3 and the square root of 13. So 9, so 3 times 3 is 9, and then the square root of 13 squared is just 13. So 9 times 13 is 117. So that's one method you can do. The other method is you can put the 3 that's on the outside back in. So that's where you get 9 times 13. And then we want to square this. So the square root and square gets away, and we're left with 117. So since these are equal, this is a right triangle. Let's try the next one. So you want to pick the two shortest sides, 16 squared plus 24 squared. Let's see if that is equal to 29 squared. So we got 256 plus 576. Is that equal to 841? We get 832. 832 is less than 841. But we got to be careful what's supposed to be less than or greater than. So notice, remember, this is c right here. So c squared is greater than a squared plus b squared. This is what we have. Okay, I just moved them around. Okay, and that matches this one. So obtuse. Alright. So this was originally a squared plus b squared is less than c squared. That means c squared is bigger than. Alright, checkpoint 1. Tell whether the triangles shown are right triangles. I assume it's on the next page. There we go. So 4 squared plus 5 squared, does that equal 2 root 10 squared? Okay, so I'm going to apply this squared to both of these. So I got 4 times 10, which is 40. This one is 16 plus 25, so I got 41. Okay, that's bigger than 40. So that means c squared is less than a squared plus b squared. So this is acute. Alright, let's try the next one. 15 squared plus 18 squared. Does that equal 3 root 61? Now, if you're unsure which side is largest, just go ahead and punch this into your calculator and you'll know that it's actually bigger than 18 or 15. So here we go. So 225 plus 324, does that equal 3 times, so this is the square root of 9 times 61 squared. 9 times 61 is 549. Is that equal to 549? Yes. Which is a right triangle. Alright, example 2. Can a triangle be formed with side lengths 2.8, 3.2, and 4.2? So this is a very old theorem from last semester. Can a triangle be formed? So remember, the two shortest sides added together must be bigger than the last side. And in this case, we get 6.0 is bigger than 4.2. So yes. So this triangle inequality theorem says that if you pick any two sides of a triangle, you add them together, must be bigger than the third side. And of course, if you take any of these two, add them together, you will get, it'll work. So if the triangle can be formed, will the triangle be right, acute, or obtuse? So this is when we do 2.8 squared plus 3.2 squared. Is that bigger than, less than, or equal to 4.2 squared? So you punch this into your calculator, and I'm going to get 7.64 on this side. And if I add these together, I'll get 18.08. So c squared, in this case, is 7.64, is less than, 17.64, is less than a squared plus b squared, so that is acute. Alright, let's do it again. Is 6.1 plus 9.4 bigger than 11.3? Yeah, it is. 15.5 is indeed bigger than that, so yes. And now we gotta do 6.1 squared plus 9.4 squared. Is that bigger than 11.3 squared? So 11.3 squared, that'll be 127.69. And then 12.2... oh, wait a second. 6.1 squared is 37.21 plus 9.4 squared, which is 88.36. All right, so c squared, which is 127.69, a squared plus b squared is 125.57. So c squared is bigger than a squared plus b squared, so obtuse. Alright, you are helping to install a small light pole in a parking lot. The base of the pole must be perpendicular to the ground, which means right angle. Using a tape measure, how can you make sure that the base of the pole will be perpendicular to the ground? So, in order for a line to be perpendicular to a plane, you must show that the line pole will be perpendicular to two different lines in the plane ground. So you're basically using right triangles. All right. Hopefully that helped you out. Have a good day.